Welcome to writing piecewise functions in terms of unit stem functions. So the idea here is imagine if we have, imagine a piecewise function. I'm right now just going to use constant functions because it's easy to imagine it going on forever. And things with slope 1. So let's imagine a piecewise function that starts off just with the line y equals t. And then maybe after that, we have something constant, and then maybe we have a gap, and we have another piece that's constant, up maybe at 2 instead of 1, and then let's say that we have a piece connecting there with slope -1. So now what we're going to do is we're going to try to build this using unit step functions. So we can build this using step functions. Essentially by subtracting off the part we don't want and adding on what we do. So what we can imagine is we can imagine starting off with that whole line, y equals t, but then subtracting off the part we don't want from the unit function. So we'll essentially subtract off let me do that in red, actually, keep the same color I was working in. We'll subtract off what we don't want. And then we'll add in what we do want. And then for the next piece, we would have to subtract off the horizontal line we no longer want. And we would need to add in the next component of the function. I will do this formally with function notation and actual formulas in just a moment. So if you cannot see what I'm drawing, do not worry about it. I will do it in more official language in a moment. Again, we will then subtract off the sort of remainder of that piece and then add in what we do want. So formally, what we want, the process is, if we have a piecewise function, f of t equal to, let's say it's defined as f1 of t for t less than t1. And then maybe it's defined by the function f2 of t for t1 less than or equal to t less than t2. And let's say it's defined all the way through fk of t for t2 tk minus 1 less than or equal to t less than tk. So we're going to build this in pieces. So we will build our function in pieces. So we will start with f of t is equal to f1 of t plus whatever, right? So this is defined sort of for the entire beginning of the graph. We start off with f1 of t. So this is correct up through t1, and then after it's wrong, and the value is equal to f1 of t. So at this point, this first part here is correct until t equals t1. And then it's equal to f1 of t for t greater than or equal to t1. So that's not what we want. So now what we need to do is we need to correct for our next step. So now we will do a correction for the next component. I need to give myself plenty more space, 1 moment. And so the next stage, now let's go ahead and make it so that it's correct all the way up through t2. So now let's fix the function so it's correct up through t2. Or up to t2. So the way we will do that is we will start off with f of t is equal to f1 of t. And now we want to leave it alone up to t1. So we will use the step function evaluated at t minus t1. That multiplying by that up through t1, it'll be like we add 0. And then from here, we need to get rid of what was already there. So currently the function looks like f1 of t. We don't want f1 of t, so we'll do a negative f1 of t. That'll get us to 0. And now we can add in what we do want, f2 of t. So now, and then we don't know what'll be after. So putting this all together, this now will be f1 of t for t less than t1. Then for t1 to t, for greater than t1. So let's do for t1 to t2, it would be f1 of t. And then we would have minus f1 of t plus f2 of t equals f2 of t. And this is what it will be for t greater than or equal to t1. So this is correct until t equals t2, at which point it's f2 of t when it should be f3 of t. So our next stage then would be to correct at that point. So now we'll correct up to t3, doing the same sort of deal. So we'll do f of t is equal to f1 of t plus u of t minus t1 times negative f1 of t plus f2 of t. Then this was equal to f2 of t for the point we need to correct. So now we're going to have to correct it after T2. So we'll do U of T minus T2. That will not change things up to T2, but it will change things beyond T2. And then multiply that by negative F2 of T plus F3 of T. So remember, the old component was equal to F2 once we got far enough along. Now this will take away the F2 that we don't want and instead add an F3, which is our target. So now this will be correct until T equals T3. And then for T larger than T3, it equals F3 of T. And so we have just this continual correct, correct, correct. So in the long run, in the end, we should have F of T is equal to, we would have F1 of T plus U of T minus T1 times negative F1 of T plus F2 of T. And then we'll keep going until we hit U of T minus, sorry, I should not have actually ended this one. This should have been, our FK should have gone from TK minus 1 on forever. So here we'll go U of T minus TK minus 1. And then we should multiply that by negative F sub K minus 1 of T plus F sub K of T. So each time we go for our next step, we subtract off the previous function and add on our target. So this is how we'll go about doing this. I'm going to work with an example so we can see this process in practice. So let's go ahead and, oh, that should not say re-with, that should say rewrite. Rewrite the following function using unit step functions. So f of t starts off as 2t for t less than 3. Then it switches to -1 for 3 less than or equal to t less than 7. After which it switches to t squared plus 4 for 7 less than or equal to t less than 10. Then it becomes 3t plus 5 for 10 less than or equal to t less than 15. And then finally, it's 0 for t greater than or equal to 15. So when we do our initial step, we'll have f of t is equal to 2t plus something. That's our initial step. Now we'll make the correction once we hit t of equals 3. So then we would do f of t is equal to 2t plus u of t minus 3 times, we want to get rid of the previous function, so we should subtract off 2t. And then we want to add on our new function, so we will add on -1. So again, for t less than 3, u of t minus 3 equals 0. And so that second component just disappears and we have 2t. For t3 or larger, u of t minus 3 is equal to 1. And so we would have 2t plus -2t, that cancels out. And we're just left with the -1 we were aiming for. Then we have something else tagged on. Next step, we are aiming for t squared plus 4 once we hit 7. So I'm going to just label this first one is correct for t less than 3. The second one I did was correct for t less than 7. This next one we're going to do is going to be correct for t less than 10. So again, we have f of t equals 2t plus u of t minus 3 times negative 2t minus 1. Then we should do plus u of t minus 7. We're correcting for once we hit t equals 7. Our new target is t squared plus 4. The previous target was negative 1. So we need to subtract off the negative 1 that we had previously. And now add on our target, t squared plus 4. And then, of course, we have unknown after that. So again, for t greater than 7, or for t greater than or equal to 7, both of those unit step functions will now be equal to 1. So we would have 2t minus 2t would give us 0 minus 1. And then minus negative 1 will get that back to 0. And then we are just left with a t squared plus 4. Now let's go ahead and make it so that it's correct up to 15. So for correct for t less than 15, we would be looking at f of t is equal to 2t plus u of t minus 3 times negative 2t minus 1 plus u of t minus 7 times, that would simplify to t squared plus 5. Then we would need a u of t minus 10. Right? We're making the correction at t equals 10. And then what we would need to multiply by, our previous target was t squared plus 4. So we need to subtract that off. We'll have a negative in parentheses, t squared plus 4. Now we need to add on our new target. Our new target is 3t plus 5. So we will do negative, then parentheses, t squared plus 4, close parentheses, and then add on 3t plus 5. And then we have unknown after that. And now finally, the last piece will just be correct everywhere. So correct for t in the real numbers. We will have f of t equals 2t plus u of t minus 3 times our negative 2t minus 1. Then plus u of t minus 7 times t squared plus 5. Then plus our u of t minus 10 times, that would be a negative t squared. Then we would have plus 3t and then plus 1. And then our last correction, we are trying to correct for anything beyond 15. So we will do u of t minus 15. Our previous target was 3t plus 5, and our final target is 0. So we would do negative our previous target, so negative and then 3t plus 5 in parentheses. And then we need to add on our new target, so we'll just do plus 0. And this is equal then to that piecewise function we had. For an alternative notation, which you are welcome to use. So for an alternative notation, let me do this actually in another color. So an alternative notation you are welcome to write u of t minus tau as u sub tau. That way you don't have quite as much to write out. And then, so we could write this as u sub tau of t. So if you wanted to write it this way, then you could write it as f of t is equal to 2t plus u sub 3 time, or u sub 3 of t times negative 2t minus 1 plus u sub 7 of t times t squared plus 5 plus u sub 10 of t times negative t squared plus 3t plus 1, and then plus u sub 15 of t times negative 3t minus 5. So this is a perfectly acceptable alternative. I apologize, that last bit of the screen didn't update. One moment. So as I said, that last term then would have been u sub 15 of t times negative 3t minus 5. You're absolutely welcome to use either of these notations. It essentially just takes our piecewise function and puts it in terms of a step function multiplied by other functions. This is useful because now we can go ahead and take the Laplace transform of this. So in the next video, we will look at taking the Laplace transform of just piecewise functions in general. And we will do so by translating into so the function is written in terms of unit step functions, and then take the Laplace transform from there.